Hello everyone, today I'll be showing you a very important method regarding quadratics, and that is to convert standard form into vertex form. What makes vertex form so special is that we can find the points of the vertex very easily by doing h, k. So h is the x-coordinate and k is the y-coordinate of the vertex of the parabola. Also known as steepness, so that tells us a bunch more than this form about what the parabola would look like. However, one thing that's nice about the standard form is that we can factor it quite easily most of the time. So we know that c has two factors that will add up to make b, right? And when this works out, we can easily find where the x-intercepts are. However, when this does not apply, so I can't find two factors of c, of the third term, that will add up to give me b, then we should use a different method, and that's where the vertex form really helps. So I'm going to start with my standard form equation here. Before I actually get further into making a perfect square and all for my vertex form, I want to isolate this a. So I'm going to, first of all, place a outside of brackets or factor it out. Remember, at this point, I haven't changed any value, and that's what we'll be doing throughout. We won't change the value, we'll just convert it into a different form. Okay, now we have something easier to work with, and it looks already a little bit more like the vertex form because we have a, and then we have a bracket. But what else did we have in the vertex form? Let's look back. We had a, and then we had brackets squared. So technically we had a perfect square. Essentially what I'm saying is that I want to have an expression written in the form as x plus p squared inside here, inside this bracket. But how am I going to convert it into that form where we have some integer here? How do I know what integer this is? Especially when I don't even have two factors of c that will multiply to give me c and that will add up to give me b. What I'm going to do is I'm going to isolate minus 4. What's of most importance is x squared plus 6x, because these are the two terms that I'm going to add another term onto, which is going to look like b, which is 6, divided by 2 squared, in order to get something in the form of a perfect square. But why would I be adding my second term divided by 2 squared? Like, where does this come from? Aren't we trying to write x plus p squared, so a perfect square, into our brackets? Isn't this the same as x plus p times x plus p? Yes. If I expand this even further, I'll see that x squared plus px plus, again, remember, p is just any integer, some integer. I'll see that I end up with this equation, and I'm going to simplify this a little bit. So px plus px is the same as 2px, and then I'm going to add p squared again. What we have here is our first term and our second term inside the brackets. So if I look back here, I have my first and my second term inside the brackets, right? This looks quite similar, except for the fact that minus 4 is not p squared. I need to add in some sort of number that will help me turn this into an equivalent of a perfect square. The formula says that b equals 2p, right? And then I divide 2p by 2, so I divide b by 2 technically. Then I'll be left with p, right? And then I square this then I'll be left with p squared. And that is the same as this third term we were trying to find and add into our equation in order to make a perfect square. So guys, that's where b divided by 2 squared comes from. Right, back to our equation. We're going to add in something that looks like b divided by 2 squared. I'm going to take 6, I'm going to divide it by 2, and I'm going to square it. 9 is apparently the value that I can add into my equation and make a perfect square. But by adding 9 into my brackets, I have changed the value. So until this point, what we were doing is we were just rearranging the equation, but by adding in a new value, which is equivalent to b divided by 2 squared, I have changed the value of my equation. That's why, in order to get it back to its own value, I'm going to subtract something worth what I've added in. So it's back to initial value. That's why it's important to add b divided by 2 squared so that we can make the perfect square. But immediately after, subtract back minus 9. We have to make our perfect square, which we still haven't done yet. So we still have not written this in the form of x plus p squared. It is as simple as finding those two factors of c 3 times 3. And those will add up to give us 6, the same as x plus 3. I'm going to have my new perfect square, x plus 3 squared. So don't forget this other part, the second half of the equation. Now we can even simplify these constants, minus 13, right? Finally, what we could do is bring the constant, which is minus 13, outside of the brackets. Before we bring this outside of the brackets and just say that this is the answer, we must realize that the reason it is inside the brackets is that the constant is being multiplied by 5. So when bringing it outside of the brackets, I also have to multiply it by 5. Now I can write this as 5 times x plus 3 squared, this part, minus my constant brought outside of the brackets. Yes, our vertex is minus 3,65, and our form looks like this.